Welcome to another lesson for building feature-rich text encodings for Python. In this particular lesson, we're going to dive into how we can just use a pre-trained model in the form of GPT-2. And this model is used or was created by OpenAI, and they used millions and millions of dollars in compute in order to generate this really powerful model. And you might have seen it in terms of how it promised to create fake articles and the like. It's a very, very powerful model, and we're going to look at how we can leverage some of that information in order to build a machine learning model for our very simple task. And let's see whether it does a better job out of the box compared with just using TF-IDF. So to start off with, how do we use this model? And to use this model, the easiest way is just to download something that's pre-built. I'm going to use ONNX, which stands for Open Neural Network Exchange. It's a format that is more compressed, and you just require less requirements in order to run it. One of the reasons for doing this is because dealing with TensorFlow or PyTorch in terms of serving data is always very, very annoying. So to get started with this, just go to the page of where there's a model zoo and just download the version of the model that you want. What I'll note for you here is the output of this model is just the last hidden state. It doesn't actually output the tokens or the next prediction that you might be interested in some of the machine learning articles that you might read about this model. I'll go through this in a bonus session, how you can actually convert this last hidden state to a prediction of the very next token that you should read in. But for now, just have a download and just drop it into your environment. So I'm going to do that because I have previously downloaded it, and I'm just going to drop in the model right here. And then what I'm going to do is I am just going to bring over some code to show you how to do this and how to read in the model. So to read in the model, you need to use the ONNX runtime as a backend, or you can use Torch or TensorFlow if you have that installed as well. But I'm going to show you how to use the ONNX runtime. So to do that, there's not that much boilerplate code in terms of which demonstrates how you would do this online. So it's probably important to walk you through step by step. I'm just going to copy and paste some of the imports that you would need to start off with. Now, what's important is you do need the GPT-2 tokenizer, which I've used from the transformer library, which is from Hugging Face. This is because you do need some way of tokenizing your text to convert it into some representation that can be read in a neural network. All right. From here, what we need to do is we need to bring in the tokenizer and also load in the model. So let's firstly bring in the tokenizer, and then now let's load in the model. So model is equal to load model.ONNX, and this should be in quotes. Okay. From here, what do we want to do? We firstly need to prepare the model. So preparing the model is actually quite expensive on the computer. So let's have a go and see what happens. Prepare. So it's backend. .prepare model. I'm just going to use CPU. All right. And so we've loaded that. Now the very next step is, well, how do I convert a sequence of tokens into something that runs through the model? So to do this, let's just create some text. Hello world. And let's run the tokenizer over it. So tokens, NumPy array, and I'm going to use tokenizer.encode for my text. The other thing that we need to do is we need to encode the type as long, because that's what is expected in the model. And if you look at the shape of this, you'll see that this is 112 because there's 2 words. I've put this as 1 because the sequence length is 1, just in case you had multiple sequences of sentences that you need to worry about, and the batch size is 1. Okay, so from here, when we want to calculate the output, what do we do? So to calculate the output, I'm going to call it outputs dot rep dot run for my tokens. Now when you get this output and you have a look at it, you'll notice that there's a length that is greater than 1. So what do you do here? Now if you read the documentation, you'll see that the output of the model is, the first one is the last hidden state. This is actually what you're interested in. The other thing is pass, which is a pre-computed hidden state. This is probably more important when you do more complicated things and you want to say calculate one thing and then feed in the past hidden states to the next part of the model in order to do some pre-compute. So it doesn't have to run through the whole model every single time. In our instance, it doesn't really matter, so we can just sort of throw that away. But what does it look like here? You'll see that when you run it, you'll see that there's 2 and 7, 6, 8. But what happens is that for every single token that you have, it generates an embedding. What we're actually interested in this case, is the very last token, because that will show you the full context. If you like, I'm going to interpret it as a full context for the very next token, which we can say is, well, what's the prediction for the very next thing that is important given the past history of all of the text that we have. Now you can do other transformations here, like taking the average if you like. So then that will be like, what's the average weight? But I'm just going to use the very next one in this case, simply because, well, I think that's relevant, and also it ties in nicely with how do you use the output in order to generate the very next token in the bonus lesson that I'll have for this course. Okay, so given that, what do we actually want to do? We need to run this and generate something that generates the very last token for this as well. So maybe I'll just quickly generate it for this one. So 0, and what we're after is 0, 0, -1, and probably the full vector, right? And then you just get something that's flattened like that, and that will be for the whole document. The other reason why this is important is because if I change this to this world, you'll see that the output will change, like the weights will change, because it gets a different context, which is what is useful about this model compared to the bag of words. So just to show you that this works, if I change the text to world, and hopefully the output will change. You can see that it's a little bit different because the next predicted word is different, and therefore we should get a different score in terms of what happens in our model. Okay, so what has this got to do with anything related to how we encode text? So what we want to do is we want to run this for every single instance in our data set. So let's have a look at how we might do that. So the very first thing is, well, we can just copy over the code that we have in our previous lesson, because we're just reading in the same data set, right? So let's just start off with that. Okay. However, this is where things start to change a bit, because as I said, I want to build a pipeline for this, right? Yeah. However, this is where things start to change, because I said I wanted to build a pipeline for this, right? So to build a pipeline for this, we need to start introducing a different transformer. No. Yeah, okay, show that. Maybe I'll just stop it here. Okay. All right, and this is all I wanted to show you for this particular lesson. In the next lesson, we'll look at how we can begin to integrate this into scikit-learn.